gee. Oh, hey, you know, three-digit numbers are kind of hard to handle, aren't they? Well, it's because they're so big. But it turns out that if we think about what the three-digit numbers actually mean, it turns out we can do all sorts of interesting riddles. I want to show you a really challenging riddle that you and I can do together. Let's check it out and have some fun. Okay, now, the sum of a three-digit number and a one-digit number is 138. The product of those two numbers, in fact, has to be 536. And the last clue we're given is that one number is between 130 and 150. The question is, what are the two numbers? Well, there's lots of numbers rolling around here, so let's be systematic in our thinking and see if we can figure it out. So, first of all, I'm going to write down the three-digit numbers possibilities here and the one-digit number possibilities here. Now, what do we know about these two things? Well, we know that the sum of these numbers will have to always equal 138. That's one of the properties that these two numbers have to have. Well, and if one of the numbers is between 130 and 150, that has to be the three-digit number, of course. Well, that means that the smallest number we could have would be 131. And what's the largest? Well, would it be 149? Well, that doesn't make much sense because remember, if I take that number and add a one-digit number, the sum has to be 138. It means that, in fact, it can't be any larger than 137. So, we're looking for three-digit numbers that start at 131 and go all the way up to 137. Look how I'm using all the facts to actually put down a total list of reasonable possibilities for the three-digit numbers. Okay, so the first one we know is 131. 131. Then the next possibility would be 132, 133, all the way down to 137. And this is like one of those cooking shows where I actually did all this in advance. Good. Okay, so there it is. Now, we have to now put in possible one-digit numbers. And what's the condition? How will we know what one-digit numbers we should actually pair up with these three-digit number candidates? Well, the answer is that we know by one of our clues that the sum of this number with this number has to be 138. So no matter what we put here, we have to make sure that it's a number so that the sum is 138. So I'm going to write that in right now, 138. And that's going to be the same no matter what, because in fact, the sum has to be 138 no matter what. So all these have to be 138 because that's going to be the sum. Well, that's going to allow us to figure out what the appropriate possibilities are for each one of these, right? Because what do I have to add to 131 to make it actually equal to 138? Well, the answer, of course, is 7. So here, this has to be 7. That's a one-digit number, and its sum, the sum with these two is 138. And then we can go down and see, so 132, what do I have to add to 132 so that it actually adds up to 138? Well, the answer, of course, is 6. And actually, if you think about it, the number is just going to drop by 1. And again, I've done this in advance. And let me just review. For example, let's look at the very last one. Why is this a 1? Well, because 1 plus 137 gives me 138. So the facts that we've used so far about the sum and at the three-digit numbers between here and here, we've now exploited all those because we see now all the possibilities. But which one is the right one? Well, there's one clue we haven't used yet. You see what it is? It's that the product of the two numbers has to equal 536. So hopefully that last clue will allow us to figure out exactly which one of these possibilities is in fact the answer. So let's just think about it together and see. You know, I can actually do this kind of quickly because I can say, you know what? If I take this number and actually kind of approximate it by something smaller, let's say 100, so this is actually larger than 100, but 100 times 7 I can do in my head, that's 700. That's much, much bigger than 536. So I know these two can't be reasonable. And even this one, if I round this down to 100, so I estimate it as 100, which is a smaller estimate. If I multiply that by 6, that's 600. That's still way too big. So the first candidate I'll really consider in earnest is going to be the candidate 133 and 5. Now, if you didn't see that, you could try to multiply these out. It'll take a little bit of time, and you'll see that the answer is way too big. It's bigger than 536, and similarly here. But let's try this and see if we got lucky or not. So what do I want to do? I want to multiply, of course, 133 by 5. Now, remember how to visualize this, and this is what I was saying earlier. What do these three-digit numbers mean? It means that I have 100 and 3 tens and 3 ones, and I'm going to multiply all of that by 5. And we can visualize that with this wonderful model, which I really, really like. In fact, I'll move the model down here so you can enjoy it with me. Because here's the 100, there's the 30, and there's the 3. And if you add all those up, you see 133, and there's that. And then if I want to multiply it by 5, it's like as though we're trying to find the area of all these little rectangles, how much there is here. So that we can actually do really easily. We have to take 5 times the 100. That's pretty easy. And then we take the 5 times the 30 to find this little region, and then 5 times the 3. And I'll just write all those down. So 5 times the 100, that's going to actually be 500. That's pretty easy. Then the 5 times the 30, that's actually easy too because it's 3 tens. And what's 5 times 3? Well, that's going to be 15. So I have 15 tens, which is 105 tens, or 150. And then 5 times 3, well, that's just 15. And now if I just add up the answers, because we have this region and that region and that region, so all together we just add, and what do we see? I see 0 plus 0 plus 5. 5. 0 plus 5 plus 1 is 6, and 5 plus 1 is 6, and so we see the product is 665. Do we like that? Well, no, we don't, because remember, we're told in the riddle that the product has to be 536. That's too big. That's too big, so we know that even this answer, which might have worked, is still too big. So let's try the next answer. Okay, so let's try the next answer. Try the next answer. I'll just get rid of this. Say goodbye to this. Goodbye. Bing! Okay, so let's try the next answer. So we'll multiply. Now we're going to multiply 134 by 4. And remember, we're looking for a product of 536. So same exact idea. We can think about what exactly it means to say 134. It means we have 100s. We have 3 tens, and we have 4 ones. If I multiply that by 4, we're trying to find this area here, which is 4 times 100, and 4 times 30, and 4 times 4, and we just add them all up. So 4 times 100, that's easy. That's just 400. And then 4 times 30, well, that's 4 times 3 tens. 4 times 3 is 12, so we have 12 tens. Well, 12 tens is actually 100, and then we have 2 tens, so that's actually going to be 120. See, I'm doing this in my head. It's kind of fun. And then 4 times 4, even I know, is 16. Please. And now to find the product, we want to look at this area, and that area, and put them all together. So we're going to add. And 0 plus 0 plus 6 is 6. 0 plus 2 plus 1 is 3. 4 plus 1 is, woo, 5. Check it out. I'm so happy. Because that's exactly 536. Now, there might be other answers that are correct, so I'll leave it to you to actually check that if you multiply these two numbers together, the answer will be too small, and that actually tells us that as we go down and the numbers get even smaller, the answer will still be smaller and smaller still, so we're actually going to go far below 536. So this is the only answer, and I see that the answer, in fact, is right here. Well, actually, you know what? I don't even like that. Let me undo that because the answer is really here, because we're looking for those two-digit numbers. So those are the two numbers. Those are two numbers that have the property that when you add them up, you get 138, and when you multiply them, you get 536. We have solved the riddle. Well, it's amazing the power of looking at mathematics in a way where you can even make huge, huge three-digit numbers, which you can barely handle. In fact, whoa, 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 whoa. You see, it's hard to handle three-digit numbers, but when you use mathematics, it will always give you a good grip. Have fun thinking about math, and I'll see you soon.
Okay, so let's take a few minutes and let's practice multiplying using partial products. I know what you're thinking, partial products, what is that? So basically, we're doing the same thing we did in the previous lessons when you're using that area, that box model to multiply, but we're just breaking it down a little bit further. Okay, so we're using place value and partial products to multiply by one-digit numbers. Let me show you an example. So if I have 6 times 182, okay? Now, I want to know what is my product. What I'm going to do is I'm going to start by this time rewriting my problem up and down, just so I can show you what it's going to look like in your work and in your book. So 182 times 6, okay? Now, I'm going to start by taking 182 and thinking, well, what is its place value? What am I actually multiplying? All right. So when I multiply, I'm going to start by multiplying in my ones place. So I'm multiplying 6 times 2. Okay. And my product of 6 times 2 is 12. Then I'm going to go multiply that 6 times my tens. I have an 8 in my tens, but that 8 is not worth 8. It's in my tens, so it's worth 80. So I'm going to multiply 6 times 80. Okay. 6 times 8 is 48, and add my 0. So now I've multiplied in my tens place value. Now I'm going to multiply in my hundreds. 6 times my 1 and my 100s. But that's not just a 1, it's in my hundreds, so it's worth 600. Multiplying 6 times 100. 6 times 1 is 6. I'm going to add my 2 zeros. Okay? Now these numbers, I'm going to add them together. So I'm just going to write them. 12 under my problem. I don't have much space here. And 600. The color so you can see where they came from. Okay. Now let's go ahead and add 2, 9, and 10. So it equals 1,092. Okay. So let me show you another way. And actually, if you wanted to break this apart and do the area model and check your answer, you certainly can. All right. So we look at those partial products. We're looking at the place values of the ones, the tens, and the hundreds, and we're multiplying them by that initial number. Okay. Let's do another example. What if I have 3,627 times 3? Let's break it apart. Let's start by multiplying my 3 times my 7 and my 1s. Okay, what is 3 times 7? It's 21. So then I'm just going to write that 21 in my answer. I'm still making sure I line up my 1's place value and my 10's place value. Next, I'm going to go multiply that 3 times the 2 in my 10's. But you have to remember that 2 10's is worth 20. So multiply 3 times 20. 3 times 2, 6. Add your 0. My answer is 60. I'm writing that 60 underneath the 21. Now I'm going to go multiply by my 100s. I have a 6 in my 100s. I need to multiply that by 3. Notice that 3 is getting multiplied by every single number in your top number. 6 in the 100s is 600. 3 times 6 is 18. Add 2 zeros. Now, I have 1,800. I need to write this underneath my other 2 products I have in my problem. I need to make sure I line up my place values. 0 in the 1s, 0 in the 10s, 8 in the 100s, and a 1 in the 1,000s. Okay. Now, let's go multiply by that last number, which is a 3 in the thousands. Three times 3 is 9. 3 zeros. So 3 times 3,000 equals 9,000. And now I'm ready to add. The 1s, 8, sorry, my place values aren't lining up very well. Apologize. So 10,188 is my final product. All right. I'm going to do another example. I'm going to go a little bit slower, and I'd like you to do it with me. Okay, so grab a piece of paper and pencil, and I want you to do this with me. Here's our problem. 471 times 4. Let's start by writing, this time, all my multiplication problems out before I solve. I'm going to start by my 4 in the bottom. I'm going to multiply that times 1. So my first equation is 4 times 1 equals. Next, I'm going to write my multiplication equation out for my tens. So my 4 times my 7 and my tens. And that's in the tens place value. So 7 tens is equal to 70. I'm going to do the same thing with the 100s, the 4 and the 4 100s. Now go ahead and pause this video, and I want you to multiply, okay? And solve our first tens that are ones are tens, then your 100s. Write the product for each one and come back and check your work. Let's go ahead and multiply, check your work. 4 times 1 is 4. I go to my tens. 4 times 7 is 28, and 1 0. And when I multiply by my 100s, 4 times 4 is 16, and my 2 zeros. Okay, that's the answers you should have gotten for those 3 multiplication problems. If not, go ahead and look at your problems and see where your mistake is, and then we'll keep going when you're ready. Now that we have our 3 products from our ones, tens, and hundreds place values, we're going to write our addition equation underneath. As for these numbers, so 4 times 1 was 4. 4 times 70 was 280. And yes, I'm writing these numbers backwards on here, just so I make sure I have my place values lined up, and you can do the same if you'd like. And then 4 times 400 was 1,600. And then I'm going to add these up together. 4 in the ones, 8 in the tens, 8 in the hundreds, and a 1 in 1,000s. So this tells me that 471 times 4 equals 1,184. So a lot like that area model, where you're breaking 471 up into 400 plus 70 plus 1. Okay, and you could use this equation here to break it up and multiply using the area model, that box model, to see if we answered it correctly, if you would like. We're using partial product. Let's try one more. 8 times 2,345. Okay, so let's start now by, actually, I'm going to rewrite this problem up and down to make it a little bit easier for me to solve. 2,345 times 8. Let me erase. All right, so let's start by multiplying it out. Write your multiplication equations. 8 times 5 for my ones. My tens, there's a 4 in my tens. So when you're writing that out, make sure you make that 4 worth 4 tens as 40. Do the same for your 100s and your 1000s. Take a minute and check your multiplication equations and see if they are the same as mine. If not, go ahead and fix them. And then pause this video and I want you to multiply. Find the product of those 4 multiplication equations. Okay, so let's go back and check your answers. 8 times 5 should be 40. 8 times 4 is 32. Add your zero, so you get 320. 8 times 300. 8 times 3 is 24. Add your 2 zeros. And 8 times 2 is 16, and we're going to add 3 zeros. Add my commas. All right, so 8 times 5 is 40. 8 times 40 was 320. 8 times 300 is 2,400. And 8 times 2,000 was 16,000. Big numbers. Okay, now that you have your 4 products, we're going to transfer them over to our equation and the answer so we can add. Go ahead and do that, starting with the first one of 40 in the ones. And make sure you line up those place values so that you can add. Once you've done that, pause this video and add. And come back and check your work. All right, so let's add 0. 4, 2 is 6. 3 plus 4 is 7. 6 plus 2 is 8. And 1. So we should have 18,760 as our answer, our product, when we're using partial products to multiply. You're going to be practicing today using partial products to multiply and looking at that place value and using that expanded form to help you. Your teachers are here to help you, so please ask or refer back to the video.